My topic to present is entitled Towards Measuring the Adaptability of Service Compositions. I'm Khavee, Botangen. This presentation contains some background concepts, the motivation and the problem definition for this topic, some related work, measurement metrics, and a simple use case to show the applicability of the metrics, and conclusion. So for the background concepts, I want to mention about web service composition or service composition. So service composition is a subset of the service-oriented computing paradigm. So it's the combination of existing web services to compose or to create a more sophisticated web service. So we call that web service a composite service. So this is one of the modern approaches of developing or designing distributed systems. So a web service is characterized as a self-contained, self-describing, platform-independent application which can be invoked across the web. So through these web services, we can create a more complex service, which is called a composite service, which later on can also be invoked as a web service, other composite services. So some benefits of service composition. The first benefit is obvious. A single service, if taken alone, may not satisfy a user need. So we have to aggregate these services in order to, we have to combine these services in order to satisfy a certain goal. Organizations can expose their individual systems as web services as well, so that others may use it, other organizations may outsource it, and this allows organizations to provide a one-stop shop for their customers. Through service composition, costs are reduced and the risk of building new applications are reduced, such that the existing business applications or systems encapsulating business logic can be exposed as web service, which could be reused by others also. So to look at service composition, underlying service compositions are business processes. So I have here a simple example of a business process for travel booking. So a customer submits a request for travel. Then the process will check the request. Through that request, the process will book a flight and book accommodation for the customer, then returns a travel plan to the customer. So a simple business process which can be executed by composing several services. So for example, task T1 could be performed by service S1 in the service composition, and so on, T2 for S2. So we have 4 services all in all, which will be composed in the composition. So service compositions realizes service-based systems. In service composition, we need to have a language to specify the composition. So the de facto language, the de facto standard for specifying service compositions is the BPEL or WS-BPEL. So Web Services Business Process Execution Language. So it is strongly supported by industry and the open source community, and a number of BPEL engines have already been developed. So these engines are used to deploy and execute service compositions. That's why for this work, we want to look at the adaptability as an essential quality of service compositions. We want to evaluate adaptability because of some of these reasons. So software systems are embedded in dynamic context where there are continuous change in requirements, the environment assumptions, and the preferences of users. So we look at adaptability as a key requirement for software, for service compositions. the capability to adapt to these changes, to continuously provide the required functionality and quality of service. So we call also adaptability here as variability or flexibility of systems or of compositions. As well as adaptability contributes to other vital quality attributes such as reusability, portability, maintainability, and scalability. So our motivation for this work, we look at the significance of adaptability in the overall quality of systems. So this suggests that its design, evaluation, the design, implementation, and evaluation should be looked upon throughout the life cycle of service composition. So the first step that we see in this goal is to quantify it. Why? Some reasons, a concrete measurement will raise process designers or developers' awareness for process adaptability. This leads to decision making towards a quality composition. So this will be helpful in the quality assessment during composition or during the development of service compositions. And this will improve the design of a process such that processes or different configurations of services can be compared. Okay? So some research questions. However, adaptability can be seen in different perspectives or various perspectives. So there are a lot of dimensions and interpretations for adaptability. That's why we raised a question such that what adaptability dimension is to quantify, is to be quantified, and how to quantify that particular dimension. This is the question being raised in this work. For those questions, we set objectives to identify the adaptability dimension to consider in service compositions. And for each dimension, to create a matrix to quantify that adaptability dimension. So some related work and notions of adaptability that we consider in this work. I have here several works which also can be related to this work. So adaptability to quantify adaptability, architectural adaptability quantification. So this shows the different perspectives being considered in adaptability. And for this work, we want to look at the binding variability in service composition, especially on compositions expressed using the BPEL or WS BPEL. So we define binding variability as the variability or the variability of a process to bind to concrete partner services. As we see in this figure, we have here a transformed BPEL process of a business process. So this is the BPEL transformation of this process, which we presented earlier. Then we want to look at the variability of this process in choosing the concrete services or the concrete partner services. For example, to perform the checking of request, we need a service which will be invoked here, S1, which there are several concrete services that are able to offer that service. So you can just call them in order for you to perform such service. So for example, for service S1, we can have two services, concrete services, CS7 and CS8. For other services, we have several concrete services that can be called. These services can have similar capabilities or functionalities. So they can perform a functionality needed. However, they may differ in their quality of performance. Okay? So the notion here is if a service cannot provide a certain functionality, a certain quality, the other services can be used. The other services that can provide that functionality can be used. So that's the notion of adaptability, okay, that we want to measure here. So the more partner services available, the higher the adaptability. So to compute the adaptability quality or dimension, we have here some methods. We set these methods to compute that adaptability. So by tagging each atomic element with a binding variability value, mapping those variability values to binding variability degree, and aggregating those degrees until we come up with the adaptability of the entire process. However, it will not be straightforward because we have to consider the behavior of the structured constructs that contain those atomic activities that binds services. So we formulated this formula for these constructs. So they have almost similar aggregation behavior. And for these constructs, we also formulated this aggregation formula. To show a simple use case of the computation or the metrics, okay, we still use similar example. So what we are focusing here are these elements invoked because they are the one responsible for the binding of services. So we tag each invoke element with their binding variability value based on the number of available services. So for S1, invoke S1, we have 2. Invoke S2, we have 3. Invoke S3, we have 2, and so on. S4, we have 1. And we aggregate those values. We compute those values through these structured constructs, switch and sequence, until we come up with the entire adaptability value of the process, which is the variability degree of the sequence construct. Okay? Yeah. For the conclusion, the adaptability of a BPEL process is quantified based on the binding variability of each invoke element. The derived variability degrees of the process elements are aggregated considering the behavior of the structured constructs in the process. Through the concrete adaptability value, process configurations can be assessed to achieve a composition that suits a desired quality. So for the future improvement of this work, we want to consider other adaptability dimensions. For example, the runtime binding variability or the variability introduced by extended BPEL frameworks. And we wanted to implement an automation tool to automate the computation for us to be able to compute the adaptability of real BPEL process specifications. Thank you, and that ends my presentation. Thank you for listening.
Yes, thank you. We have some time now for questions. So, what questions do people have? I'm sure you've got lots of questions.
I have questions.
Yeah.
For web service, you mentioned about WebSphere. Okay, SOA.
Yeah.
Yeah. And I know WebSphere is the same as WebLogic, and it's based on the application and enterprise system.
Yes.
So, what do you mean? I'm not understanding your topic, but just my some suggestion.
Yeah.
What in your service like the
Yes. WebSphere is a composition language So for you to specify, for example, you want to create your own service composition, you want to create your own application. So there are already existing elements of your application in the web.
Yes.
Use WebSphere
Yes.
to specify that application that you want.
Yes. This is exactly we used that here now.
Yeah.
Okay, this is web server. It's a component. And we probably use Oracle or what's the IBM's the other it's database.
Yes.
And this is where this is the database.
Yes.
And you create your for web service.
No, we will not create our own programming specification page. We will not create it. But this work is about evaluating the adaptability of a certain composition in order for you, for example, as a designer, look at, compare these processes or these services to come up with a quality.
Yeah.
So we're looking at a quality
the same
service
time-
composition.
The
Yeah.
same time quantity. What the web can provide. Quantity at the same time.
Quality.
Okay, the quality at the same time. What
Yeah.
the web service can provide.
Yes,
Am-
yes,
Am I right?
yes.
And what's the adaptation for your? I noticed talk about the
Adaptability, yes, yes.
Which is, for example, web sphere, we can use Unix, and the Windows. What do you mean about the adaptivity?
Yeah, adaptability here, the adaptability that we are looking at here is the ability, the capability of a process to adjust itself to changes. For example, if you deploy a process to a particular thing,
Yes.
business environment, then a rule or business rule changes. How can that process adapt to the change in business rule? So we want to compute that particular that adaptability characteristic.
Could I just step in for a second? This is an absolutely fascinating conversation. Can I just see if anybody else has any questions? Because
Yeah.
obviously you might want to have some discussion after.
Yeah.
Very
Thank you, thank you.
Yes. Does anybody else have any questions? They're very, very good questions. Thank you. Thank you. Anyone else? Yes, yes.
I'm very interested in your research objective that you say you are going to produce a matrix. Are you going to use adaptability matrix?
Yes,
Yeah.
yes.
In the previous work, is there any related adaptability matrix?
Yes, there are already existing adaptability methods, but they are focused on different perspectives of adaptability. That's why here, we want to look at a perspective wherein we are going to a runtime adaptability, because these previous works are looking at design adaptability. So we are going to look at runtime adaptability.
So you have a different purpose for the matrix.
Not really different, but we want to look at if we can propose or we can create a more comprehensive matrix that covers both design and runtime adaptability. Yeah.
We have time for one more very quick question. Do we have any other very quick questions? This has obviously stimulated a lot of
Thank you.
If we could thank you again for your presentation in the usual way.